Hello all, welcome back to Engineering Economy course. We are considering comparison and selection of the best project among mutually exclusive alternatives. In our previous lectures, we learned how to do these comparisons when the useful lives are equal to each other. And in today's lecture, we will learn how we can compare alternatives when their useful lives are different from each other. So we will see how we can implement the repeatability assumption. We will see how we can implement the co-terminated assumption under different cases when the useful life is less than the study period or when the useful life is greater than the study period, and we will learn a technique called the imputed market value technique that can be used in the co-terminated assumption to estimate the market value. So let's get started. In our previous lectures, we learned that in comparing mutually exclusive alternatives projects with each other, the fundamental principle is to compare them over the same period of time, same study period. Okay, so we may have two situations according to this principle. So if the useful lives of the projects are the same between each other and these are equal to the study period. So until now we considered this case. This was case 1. Okay, all the analysis that we learned up to now was about this case. But there is a different case, the second case, where the useful lives of the projects can be different from each other, and these useful lives can be different from the analysis period, the study period. So if this is the case, then still we need to compare the alternatives over the same period of time. So by making some assumptions, we can perform similar analysis. And what are these assumptions? The first assumption is the repeatability assumption, as we talked previously. The repeatability assumption says that you can repeat the same project after its useful life. You can continue repeating the same project, and in order to be able to apply this assumption, either the study period should be indefinitely long or the study period should be equal to a common multiple of the useful lives of the alternatives. And the economic consequences of the projects should repeat itself. When the project life is over, you can repeat exactly the same project cash flows, same economical consequences. So these are the necessary conditions to apply the repeatability assumption. And in many cases, you will not be able to satisfy these conditions. The second assumption is the so-called co-terminated assumption, in which by making some adjustments on the project cash flows, we put these alternatives on a common and comparable basis. So we will see the details of these assumptions. So now we are in case 2. We are dealing with projects with useful lives are different among alternatives, and at least one of them is different from the study period. Okay, so the first case we are going to consider is the repeatability assumption, and we talked about these conditions. Either the study period is indefinitely long, or at least it is equal to the least common multiple of the project lives, and the cash flows associated with the alternatives useful life should be repeatable, okay, in the future replacements of the project. So let's solve an example to understand this repeatability assumption better. So it says that there are two mutually exclusive alternatives A and B. for an engineering project, the useful life of project A is 4 years and the useful life of project B is 6 years. They are different. It is said that the MAR is 10%. So we need to select one of these alternatives using equivalent word methods, present word, future word, or annual word. And it says that use the repeatability assumption. Okay, so in order for us to be able to use the repeatability assumption, okay, so look, the useful life of A is 4 years and the useful life of B is 6 years. So what does it mean? If I sketch the cash flow diagram for A, it says that the initial, the capital investment is 3,500. Then for 4 years, the annual cash flow, it says that it is $1,255. The market value is 0. So this is for A. And if I sketch the cash flow diagram for B, the initial investment is this much. Now the useful life is 6 years. And the value is $1,480. Okay. Now I need to compare A and B, and the fundamental principle says that if you want to compare these two projects, these lives, this study period should be equal to each other. But as you can see, they are not. So what we are going to do? Actually, we will move them to a common basis. And how we can do? The useful lives are 4 and 6. What is the least common multiple of these two numbers? It is 12, right? So if I multiply this by 3 and this time 1 by 2, then 12 is the least common multiple. So what does it mean? It says that repeat the first project 3 times. And what does it mean repeating? Repeating means this. So at the end of its lifetime, you sketch the same cash flow one more time up to time 8. And we are assuming that the same cash flow, the same cash outflow and inflows occur. And then I need to do it one more time to reach 12. So it means that here I have 3,500 initial investment, and then for 4 years again up to 12 I have 1,255. So this is now the project A, the cash flow of project A for 12 years. And the assumption here is this initial first repetition of the project will provide exactly the same cash flows with the second repetition, and it will do the same with the third repetition. And for B, project B, we will do the same thing, and we will repeat the cash flow so that 2 times, so that we reach a lifetime of 12 years. And again, this first repetition is exactly the same as the second repetition. Now each cash flows are going until time 12. So now we can use any method, present word methods, rate of return methods, and etc. to compare these project alternatives with each other. But here it says that use equivalent word methods. Therefore, we are going to calculate either the present word or the future word or the annual word. Okay. Now the rest is just finding these equivalent values. It has nothing to do with this analysis procedure. The analysis procedure was until now. And when you sketch the cash flows, the remaining part is finding the present or future values and etc. of the given cash flows. So how can you find the present worth of these cash flows? You can just find, for example, the present worth of all these uniform payment series for 12 years at time 0. Then we can shift these 3,500 to time 0 separately, and it will be done. And for the second one, again, we do the same thing. We move all these uniform payment series to time 0, and we will shift this one to time 0, and everything will be in present world. Okay, so if we do it for the first alternative, look, this is the initial capital investment. This part multiplied with this factor is the present worth of the second repetition, capital investment. And if it is multiplied by 8 years, it is the third one. And this one is P given A for 12 years, the uniform payment series. And with 10% more, the present worth of alternative A is this much. So what actually happens when we repeat this investment alternative A 3 times is we have the same cash flow in the first 4 years, repeat the same thing. This is the second repetition and this is the third repetition. And for B, we repeat it just 2 times to reach to the same time span. And for the second one, for alternative B, when you find the present worth, so this 5,000 is already at present time, and if we multiply this by P given F, and also this is the uniform payment series, we find the present worth to be this much. Now, in order to select the best alternative, we need to compare these two values with each other, and we just need to select the largest one. Okay, so in present world, you don't need to do the incremental analysis. You can select the best alternative by just looking at the largest present worth value. But if you want to use internal rate of return, for this case, again, you need to use the incremental analysis, select the base project. If it is acceptable, then look at the incremental project and try to select the preferred alternative. Actually, annual worth method may have an advantage on this method, on comparing alternatives. If we solve the same example using the annual worth method, so we will obtain exactly the same decision. The final decision will be the same. How we can find the annual worth? After finding this present worth, you can simply multiply by this factor A given P for 12 years, and you find the annual worth of A as this much and for B as this much. And when you compare them, you see that we still need to select alternative B. But the thing is, initially, before calculating the present worth, we could have used the annual worth method. And let me sketch the cash flow to somewhere here. For A, if you remember, we had such a cash flow. Then we had the second capital investment, and we had the third capital investment. Okay, and it was 8 years, 12 years in total. Okay, so now if I want to use the annual worth method, how do I find the annual equivalent of these values? So look, this part is already uniform payment series. It's already annual worth. The only thing is I need to find the annual worth of these ones, and all of them are equal and 3,500. So what can I do? And the number of years, okay, here are also the same, 4 years. So what can we do? We can just find the annual worth of this one for 4 years. So we spread this 3,500 to 4 years, and that will be exactly equal to this one, and that will be exactly equal to this one. So we don't need to do the same thing 4 times, but we just do it for only this alternative, and then the remaining ones will be the same. Okay, so what do we do? For this 3,500, I'm finding A given P, the interest rate is 10% and for 4 periods. And when I find its annual equivalent, this annual equivalent will be repeated for the others. So simply I add it to my annual payments or annual revenues, and I obtain this value. Similarly, for alternative B, I can just, since there is only one, I can just spread this 5,000, find its annual equivalent for 6 years, and add it to already annual revenues, and we obtain this value, and these are, as you can see, exactly the same with the previous one, and our decision is to select alternative B. So other than the repeatability assumption, we may use the co-terminated assumption, as we talked already, when the useful lives of the alternatives are different between each other and different than the analysis period. So what do we do in co-terminated assumption? We need to identify a finite and identical study period for all alternatives. This is the fundamental principle. All alternatives must be compared based on the same time period. Okay, so in order to compare these project alternatives on the same time period, we need to do some appropriate adjustments on the cash flows of the alternatives so that these alternatives come into a common and comparable basis. So when this approach is used when the repeatability assumption is not applicable, and this one is the most frequently used in engineering practice. So when the useful lives of the alternatives are different than the study period, we may have different situations, and for each one of these different situations, we may need to do some adjustments on the cash flow based on the difference between the useful life and the study period. So, for example, if the useful life is less than the study period, okay, if this is the case, and if we are comparing cost alternatives with each other, so what can we do? Since these are cost alternatives, it means that we require some service from these cost alternatives. Since each alternative must provide the service for the same period of time, what we can do, we can contract for service or lease some equipment at the end of the useful life for the remaining time. Okay, so for example, assume we require a service for 10 years, but there's one alternative A for which the useful life is 8 years. So this remaining time is 2 years. We cannot say that, oh, no, I can only provide this service only for 8 years. The requirement is for 10 years. So for these 2 years, we can do some contract or we can lease equipment and etc. so that we fill in this gap and we satisfy the condition for 10 years. Or what we can do, we can repeat some part of useful life of original alternative until study period ends. So the study period is 10 years, our useful life is 8 years, so we repeated the project, but it is repeated, as you can see, for 8 years, but we only need for 2 years. So what we do, we only use first 2 years. Of course, you need to be careful while doing this. If it is possible to use only 2 years or not, we will talk about this later. What will happen to the remaining project cash flows is important. Okay? But still, somehow we need to fill in this gap, and we need to satisfy the service requirements. So this is the case if the projects or the alternatives are cost projects. If the compared alternatives are investment alternatives, so what do we have in investment alternatives? Let's assume that we have such initial investment amount and then we have some earnings. So let's assume that the study period is 10 years and we invested, let's say, in some alternative A, and this alternative A is only for 6 years. So what will happen for the remaining 4 years? So as a result, we obtain some revenue from this cash flow. And we can assume that after this sixth year, we can reinvest the amount of earnings using the mar, and we can move them to the future time using mar. Okay, this is the first assumption. So any revenues that we earn from the project, we can assume that we can reinvest them using this mar, so that if we want to find their value at a future time, we use mar as the interest rate. Or it can be the case like this. At the end of the 6th year, we have this future worth of all these revenues, and we can find the replacement project, an alternative project, and invest in that project for the remaining 4 years. And then we will earn some other earnings, some other amount, and we can find the present or future worth of the cash flow in this way. So we fill in this gap either by finding another project alternative or assuming that we can reinvest that amount of money with the mar as the interest rate or the return rate. Okay, so for an investment alternative, we can do the adjustments in these ways. So in co-terminated assumption, in order to come up to an equal time period for comparing alternatives, we need to adjust the cash flows, and these adjustments depends whether the useful life is less than or greater than the study period, and whether these project alternatives are cost alternatives or investment alternatives. So let's solve this example where the useful lives are different than the study periods. So in this example, we solved the same previous example where we were comparing two projects A and B. So let me sketch the cash flow. For A, the capital investment was 3,500 and the useful life was 4 years, and we have these annual revenues of $1,255. And for B, the initial capital investment was 5,000, and then the useful life was 6 years, and the amount of revenue at each year is 1,480. Okay, now we want to compare these two alternatives, but the thing is, we are given that the analysis period is 6 years. So we cannot use the repeatability assumption, we cannot use 12 years as the least common multiple, and the analysis period is given as 6 years. So what shall we do? The thing is, this B is already 6 years, that's good. But the problem is with A. So for A, I need to extend it to 6 years. And what can I do? And I will assume that during this time, during these years, the amount of revenues that we obtain from this project can be reinvested using the mar. Okay, so if you have some future value at this time from this project, from this cash flow, then if I want to find its equivalent value at time 6, I will assume that I can get a rate of return equal to mar. Okay, so using this, we can use the future worth method to compare these alternatives. For the first one, I will shift everything to a future time. So this initial capital investment, I will find its future value. Okay, this F given P. Okay, let's first find the future value of this project at time 4. Okay, and then I will shift it to time 6. So this will be F given P, 10% is the mar and 4, plus this uniform payment amount, F given A, 10% and 4. Okay, so this is the future worth at time 4. Now what I'm going to do is I'm going to shift this one to times 6 by multiplying f given p 10%. Again, this is MAR. I'm assuming that we can reinvest in MAR and 2 periods forward. Okay, so this is how we find the future worth of part A, future worth of A. For future worth of B, so it is already the useful life is equal to the study period. So I will multiply this by f given p 10% and 6 plus uniform payment series f given a 10% and 6. And this is the future worth of B at time 6. And if you do this calculation for the first one, you will find $847. And for the second one, we will find $2,561. And now what we are going to do is we will compare these to each other, and we see that B is better. B has a higher future worth, and then we select part B. Now you may ask this question, why did we use the future worth method? Can we use another method? Can we use annual worth method? Can we use present worth method? Yes, you can do it. So actually, we are considering this. We have this cash flow and we have this cash flow. We need to compare them with each other. If you find the present worth for both of them and compare them with each other, you will come up with exactly the same decision. Okay, so this is how we compare alternatives with respect to the co-terminated assumption. So you can see the solution here. For part A, its useful life was 4 years, and for 2 years we assume that we can reinvest the amount at MAR for 2 years, and we calculated its future worth. And for B, we calculated its future worth, and instead of future worth, if we calculated the present worth or the annual worth for the 6 years, we would obtain exactly the same solution. So for co-terminated assumption, we said that since the useful lives are different than the study periods, we need to adjust the cash flows. And as the first case, we assume that the useful life of the projects, what happens if the useful lives of the projects are less than the study periods. And for cost alternatives and for investment alternatives, we talked about what we can do. But if the useful lives are greater than the study period, this is the second case. In this case, what we do, in this case, we truncate the alternative at the end of the study period using an estimated market value. So what does it mean? Assume that there is such a project cash flow. Okay, so I don't know, there are revenues, expenses, and etc. Let's say that this is for 6 years, but the study period is 4 years. Okay, so it means that the project will end here at time 4. It is the end of the study period. So now what will happen to the remaining one? So we estimate the market value of this project at time 4. And usually the estimation of the market value is finding the present worth of all the remaining cash flows at this time, at the end of this time. Okay, so this method assumes disposable assets will be sold at the end of the study period at that value. So we can use the imputed market value technique to estimate the market value of the project or the equipment at the end of the study period. If we know the market value exactly, of course, we can use that value. But if we don't know this market value, then we can use imputed market value technique to estimate its market value at the end of the study period. So estimating this market value is based on some logical assumptions about the remaining life of the asset. So we can find the market value of the asset at the end of the study period. This T represents the study period. Okay, so this market value at the end of T can be calculated by finding the estimated value or equivalent word of the remaining capital recovery amounts at the end of year T plus the equivalent word of the original market value at the end of the useful life. So we find its equivalent word at time T. So this is the case when the project study period is less than the useful life. And here we use EW to represent the equivalent word of the capital recovery amounts and the original market value by using the interest rate equal to MAR. So this estimated or imputed market value at time T can be calculated by using this formula. The first part here is the capital recovery. So if you remember the capital recovery formula, this part. So assume we have this initial investment amount and then we call it the salvage value. Okay, we were representing its salvage value, but in this equation we represented the market value at time N. So the capital recovery corresponding to this item, this equipment, is found by finding the annual equivalent of this initial investment and annual equivalent of this salvage value and subtracting. So this first part is the annual equivalent of this initial investment and the second part is the annual equivalent of the market value. Okay, so in order to calculate the market value at time T, estimate the market value at time T, what do? We find the capital recovery using this one, and then using this capital recovery, now that capital recovery is an annual equivalent expense, something like this. So what we need to do is we need to find the market value at time T. It means that I need to collect all these capital recovery amounts to time T. So I'm multiplying it by P given A using MAR as the interest rate. So this number of periods here is N minus T. Okay, so this P given A, MAR, and N minus T is used to collect everything here at time T. But plus at the end of this lifetime, this item has its own market value. So I will move it, I will shift it to time T separately. So I will multiply the market value at the end of time N with P given F, MAR, and N minus T. So this part is the market value of the item, the estimation of the market value of the item at time T. Okay, so by using this formula, I can estimate the market value at time T, which is the end of the study period, and only use this market value so that I end up the project here. I just include this market value T here and deal with the rest of the cash flow. So in order to understand this imputed market value technique better, let's consider this example. So in this example, there is a pump which with model number this, and the cash flow for this pump, the initial capital investment, the market value, the salvage value at the end of its useful life, and the electricity and maintenance costs are all provided. So this cash flow diagram gives all the information. And then it's said that we want to find the estimated market value for this pump at the end of year 5. Okay, so 5 will be the end of the study period. Now let's use this imputed market value technique to determined to estimate the market value at year 5. And what do we do? According to our imputed market value technique, we need to consider the initial investment and final salvage value, and we need to find the capital recovery. Okay, so the capital recovery will be this initial investment multiplied by, so it will be A given P. For this example, the MAR is given as 20%, and the total number of years or periods is 9. And from this one, I will subtract the salvage value 5,000. So it's A given F, 20%, and then again 9. Okay, so this is the capital recovery. And this is an annual amount for each year. And what should I do? I need to, in order to find the imputed market value technique, I need to find the capital values that are present for the years after the project study period. I need their equivalent values at time 5. So it means that this CR is here for 4 periods, and I need to multiply this CR by P given A, 20%, and 4 to find the market value, the first part of the market value at time 5. And when you do this calculation, you will find the value to be $29,949. Okay, this is the first part. So let's put a star here. It's not over yet, because in imputed market value technique, we also need to find the equivalent worth of the original market value at time 5. So what do? I multiply this 5,000 with P given F and 20% MAR, and how many years I am taking it back? It is 4 years. Okay, so its value is $2,412. And now this is the second part of the imputed market value. Then we can say that the market value at time 5 will be the summation of these two. Okay, the remaining amount of capital recovery plus the equivalent worth of the original market value, which will be $32,361. Okay, so this is the estimated market value at the end of year 5. Now what we can do, if we need to compare this alternative with another one, I just get rid of the rest of the project. I just delete this part. I include this market value to here as an additional $32,361, and now my 5-year project is this, and I compare this with other alternatives. Okay, so this is the end of this lecture. In our following lectures, we will solve some comprehensive examples to understand this concept better and summarize all of the subjects that we learned in this chapter.